Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see how to do a very simple data analysis in which we're comparing the various disease outbreaks such as COVID-19, SARS, and Ebola using Python. So let's see what we're doing. So to get our dataset, you can get it from this particular URL from GitHub. They have done a very good work of cleaning the dataset for us so that we can use them. Right now, let's see some basic insights or some basic questions we'll be trying to ask about our dataset. So these are some of the questions we'll be asking. So which countries were affected? How many cases did we get for each and every of the pandemic? What are the top countries affected? What is the trend for each disease? Then the day with the maximum or minimum number of cases, and then how long did each pandemic last? So these are some of the questions we'll be asking whilst doing our analysis. So of course, whilst you are doing it, you may have some different questions we may ask about. So let's see how to work with it. So first of all, we import our EDA packages such as pandas and then Geopandas for our plot, for our geographical plot. Then also be importing our data visualization packages such as matplotlib and then Seaborn. So let's start with working with them. So first of all, we're starting with loading our dataset. So first we will be using a simple approach. So this is going to be SARS, right? I'll call it as SARS, right? Then I'll load that particular set to PD. I don't know whether I can see it very well. PD.read underscore CSV. Then I'll pass in inside my dataset here. Further, I can just go to my pandemic SARS. So inside my dataset, I have all my diseases here, right? So we have my pandemic Ebola and then pandemic SARS dataset. So we'll be going with the SARS for the SARS option. Perfect. And then do the same thing for the Ebola, right? So I'll copy this one here. Then come back here. I don't know whether I can see it well. I hope you can see it very well. This is too big. Yeah, it is too big. Okay, so let's go. Right, so this is going to be for our Ebola. So I'll just change this one to Ebola. Right, so these are going to be for SARS and then Ebola. Right, very interesting. But let's get for COVID-19. So I'll just come back to this same place and I'll use the CLI that we created the other time. So COVID CLI, then get dataset. Right, there's a simple CLI that you can get it on PyPy. So it's going to fetch the current dataset from somewhere, right? Then you use it to do analysis. It's going to fetch it for us. Take you some time to download it. Make sure that you have internet to be able to get it. But in case you don't want to do this, you can actually get it straight away. So it's downloading it. Perfect. So just finished downloading. So I'll be using this particular dataset for our analysis, right? So I'll copy this one here. Then let's start with it. So if I come back to my dataset here, so that is there, right? So that's what we're using for the COVID-19. So let's go to COVID. Then I'll pass in pd.read underscore CSV inside my dataset. I'll just pass in this one, right? Perfect. So we are done with our dataset. We have fetched them. Now let's see how to analyze them. Perfect. So first of all, we're doing some basic analysis for the SARS, right? So there's going to be data analysis of SARS, right? Then you move on to the next one. So what are some of the things we're doing? We just check for our dataset. How does it look like? So if you look at it, we have our dates column, right? Very interesting. We have our countries, and we have our confirmed cases, death cases, then recovered cases, and then the longitude and latitude for the geography. Very interesting, right? Perfect. So now let's see the number of let's see the number of cases per day, right? Per day. So how do we do that? So first of all, we'll be grouping them in a simple way, just as we did previously. So it's going to be my, say, SARS per day. Then I'll be using a simple group by. So group by, and I'll pass in the date that I'm using. So I'm using the date column. Then I'll be grouping them together. So let's check the columns first. So I'll just come back to this place, go with SARS dot columns. Okay, perfect. So I'll be using these ones to help us to group them perfectly in a simple way. So I'll copy this one here, then let's paste here, right? Perfect. Then you use .max to group them in a very simple format. So perfect. So let's check for our SARS per day, right? You can just name it anyhow you want it to be. So this is how it is. So we started from 2003 and 17th of March, right? And this was the number of cases, this is the number of deaths, and then this is the number of recovered on this particular date. And then the last date was on July, right? 11th, right? Very, very interesting. So this is the trend. So you can actually visualize this one by going the same option. So SARS per day, then just do a simple plot. So the kind is going to be line. Then I'll just go with the figure size 2010, right? So let's try it out. I'm going to analyze and let's see the trend of how the dataset will look like. Very interesting. So from our analysis, from our pictorial or visual analysis, we like started from this month, right, on March 2003. Then it rose up. So here's it. Let's reduce it and make it 5. So that at least we can see it very well. Okay, perfect. So this is the blue is the confirmed, then the orange is the dead, and then the recovered is the green. So looking at how it is, it started like this, then it rose up, then it plateaued a little, then it rose up again, then it plateaued a little, then it rose up all along, then it came straight away, right? That is how it was. And then this is the same thing for the deaths. So the death was also minimal all through the SARS. So that means that SARS is having a minimal death, right? All throughout, the death was very low. And then for the recovered, it also was low, then it rose up like that. That is something very simple for our trend based on how it was, right? So we have been able to understand something about the trend. So let's do some simple narrative. So based on it, it's a simple trend, like it was incremental trend, right? Or we can just stop this one, otherwise it will take a lot of time. So let's take this one off, right? So let's do the same thing that we have done so far. So you have seen how it was for each and every of them, right? Based on the time it started and the time it ended, based on the data set that we have. Now let's do the same thing for our Ebola. Right? So this is going to be our analysis for Ebola. So in that case, if I go to the Ebola.head, going to see the same thing, almost the same thing, but for the Ebola we only had confirmed and then death, right? So there was no data available for the recovered. So that's what we are using so far. So we're doing the same thing. So Ebola per day, right? Ebola cases per day. Then I'll just do the same thing that I did. So Ebola, let me copy this one because it will be the same thing. So I'll copy the same thing here, then use it for this one also, right? The group by is going to be the same group by, but the only difference that this is having only confirmed and death. There is no recovered. So I'll take off the recovered, then we just run it perfectly. If I run it like that, now if I go back and I check it from here, you're going to see the trend. So the first time for the Ebola to start was on this particular date, right, which was 2014. Then it ended in 2016. That is the last time they collected that particular data, right? Very interesting. We can also do the same plot we have done, then do the same thing to plot. The kind is equal to line. Let's copy this one. Because we are doing almost the same analysis, I'll be copying and then pasting most of them. So apologies for that. We are trying to do everything from scratch. So let's start with this. Yep, and let's run it again and see. So let's check it out. Perfect. Wow. So for this one, it's totally different. As we compare, if you compare this one here, and then this one is totally different. It looks totally different. Let me bring it close by, so that at least you'll be able to do it. You can also use subplot to help you compare them, which we'll be doing later on. So this one, we can just make it like this, right? So that at least you see it well. So if you check this one and this one here, you can see the difference, right? Let's reduce it so small, like you'll be able to see it very well. So looking at what we have, it looks like for the SARS it was like this, confirmed went up, then it goes up. But for the Ebola, it shook straight away. It's a very, very inclined right and right. It rose very sharply, then it went like that, very, very fast. And then the death was also something like that, which is totally different, right? So this is an airborne disease, mostly an airborne disease, but this is not just airborne, right? This is also droplets and then all the rest. Okay, so that is something very simple, something very nice. But we can also do a subplot to compare them together. So let's try that one. So in that case, it's going to be this. So it's going to be figure, right? Let me make it bigger so that I can see it very well. So we are doing a subplot, right? So figure, and then let's give it as my axis. Then I'll go with my plt dot. Go to plt dot subplots, making sure that you are giving the number of rows you are using is using only one row, but the number of columns we're using is going to be 2, right? You use 2 columns. Then we just give it a figure size. So figure size, which is going to be 20. Let's make it 5, right? Perfect. So that is for our subplots. Now let's plot it easily. So it's going to be our axis 0 dot plot. Now pass in my SARS, right? So SARS per day. That's going to be for the SARS, for this particular SARS virus or SARS disease. Then do the same thing for Ebola. So it's going to be axis 2. There's going to be the next axis, right? It's going to be Ebola per day, and then that is all. So the next thing is that we're just going to use, we can plot it straight away. If I go straight away with this, it's going to plot it perfectly for us and give us something like this, which is not the best, right? It will work perfectly, but we can also specify a layout to close the gap between them. Perfect. See that now that's giving us in a very simple. So the number of rows that we have is 1 row, right? And the number of columns is 1, 2. So this n columns is column 1, column 2, right? And the row is this one. So you can see from here how it works. It goes up like this, and then this one goes up like this, right? Very interesting. So you can also do another plot in case you want to put it side by side. In that case, it's going to be the n rows is going to be this option. The rows is going to be 2, right? And then the column is going to be 1. In case you want it to be up and down, right? So let's run it. Then you can also, in that case like that, you can also put a tight plot, right? A tight layout. So it's going to be FG tight layout, right? Layout. So let's run it again. I hope the tight is correct. That's going to analyze it perfectly and then give it on 2 rows, right? 2 rows, 1 column instead of 1 column, 2 rows. So it's taking some time to do that. Perfect. So from here you can see the difference. See, the moment I brought the tights, that is why it has put them together. So we can even make it like 10. So I make it 10. Now you can see it clearer in a clear format, right? But with this tight, it's going to put them tight together, right? That's the meaning of the tight layout. Perfect. So that is the, see that the difference is there's some. So this is how it looks. So in case you want it side by side on top of one another, you can also do the same thing. That is something simple we have seen, right? So we can add the third one to it. So let's add the third one for the COVID-19. So in that case, it's going to be analysis of COVID. So in that case, it's going to be my COVID.head, which is going to be the same thing like our confirmed recovered deaths and then our dates. Then we'll be grouping them by date. So it's going to be COVID per day, right? We are grouping them by day, right? That is the reason. Then I'll just go with my COVID.group by, then I'll pass in my date. Then I'll do the same thing as I did above. So I'll copy it so that to save us time. It's going to be this one here. No, to be the other one. Let's use this one. Hope everybody is doing well in this quarantine lockdown. Okay, so let's check it out here. I'll just copy this one here. Perfect. So let's try it out. Perfect. So if I go back and I check for COVID per day, you can also see the time it started. So it's based on the data set that we have. It started from this place, right? 1st of January 2020, and then this is the current data point that we have, right? Very interesting. So now we can also do the same plots that we did above and then compare them on each side. So we can even do a plot like this, the same plot we did, and compare them like that. So at least now you can see it very well. So now I'm going to add another plot. So axis, and then a third axis. So this is going to be for COVID. And then I'll just pass it here, right? This is going to be 2. Then I have to change this one from 3 to make it 3 rows. So it's going to squeeze it so small. Going to analyze it, and then it's going to be seeing the difference between each and every of the diseases. Perfect. So based on this is for our SARS, our Ebola, and this is for COVID. Wow. And looking at how it is, it looks like for the COVID, it's just some way. It is, wow, it is shooting here so high, right? This is one way you can do that. You can also do the same thing that we did above, right? And put it sideways. So let's try that one in case you want to see it in a different way. So this in that case is going to be, we are giving it 3 rows, then 1 column, right? So you can also do the same thing. It's going to push them together in that aspect. Perfect. So you can see from here, this plot is very funny, right? It is going up for the SARS like this. For the Ebola, it goes up almost the same, but this is different, and the COVID is very in a different format. So this is, you see, you can see something. There's an issue here with our dates, so we can actually reduce them to maybe the first 100 days and then actually compare them. So we'll be doing that in the next instance. So we'll be getting the first 100 days and then compare them. This is just too much, right? Because some of them there was a lot of data collected, others there were a few data collected. So we just checking that maybe the first 100 days, or let's say the first 20 days. So let's try that one. So in that case, it's going to be like this. So I'll just go back and then copy the same thing, and then set the index to daytime to get the first 100 days. So let's copy this one here, and then I'll just come back down here. So this will be trying to do check for the first 100 days. We'll be checking or comparing for the first 100 days, right? Something like that. So in that case, we'll be using daytime to help us. So we'll be importing date time, right? Dot time delta. You can use that time delta to help us with that. So daytime to help us with that. Now let's check this one. So I'll just do the same thing, but I'll be loading them differently. I'll be loading them straight away, because from our data set we realize that all of them is having all the data set that we have, either the COVID.head, all of them have a date column, right? They have a date column. So we'll be trying to pass the date straight away into our variables that we are saving. So I'll just do the same thing here, right? Then I'll go with my pass dates. So the pass date is going to be supplying the dates column, right, to convert it perfectly, to convert them to daytime index. Then I'll just go back to my index, send that index to the dates index, right? Perfect. So this is something simple. So in order for us not to be confused, I'll just put something like, say, cases here, right? So that it looks totally different from the previous one. Perfect. Now if I go back to my SARS cases, not my SARS cases, but SARS cases, you can see that I just changed the format. Now the index is the date, right? So with this you can do an analysis. You can also do the same plot we did above. You can actually do the same plot to give it in a simple way. So if I can also plot the trend. So see what I did. Plot kind. So I go with line. If I plot it like this simple, it's going to plot it perfectly for us, right? Wow, this is some funny plot. But you have to do a group by to help us with this particular plot. This is not nice, and this is not the right way. Okay, so something very simple. Now let's do some stuff. You can see some stuff you can do. So in checking for this is going to be checking for the first 100 days. So checking for, say, first 100 days. So using daytime to help us with that. So I'm just going to pick from the first one. It's going to be SARS cases, right? So if I check the SARS cases, the first one is starting from this particular point. So I'll pick this date, 17th, then I'll count from this place to the next 100 days. So this is going to be for our variable. So let's go to SARS start date. These are the start dates, but the time they started collecting the data, right? That is the first one we are doing. So I'll put this one here, right? So that is going to be the start date. Right, perfect. That's for our start date. Then our end date, but we will not be getting our end date. We'll be calling that, let's say, day 100. So day 100 for stars. Right, so that's what we're trying to calculate. So how do we calculate it? So I've already gotten our date. Now to be able to calculate for date 100, you can also use a daytime option to help us with that. Okay, so that is what be trying to check, right? So this is the date we'll be using. So I'll just copy this one here. Let me run this one. So let me copy this one. So we try to check that particular one. So this is off, and let's work on this option. So this is the start date for SARS, right? Perfect. So to get the 100 days, we'll be using daytime. So I'm just going to import daytime as we did. So daytime, right? We already imported it. Then we're using time delta to help us with that. So it's going to be something simple. It's going to be date time dot datetime dot time delta time delta, right? So that is one of the things we'll be using to help us with that. But before we do that, let's strip time. We'll be stripping off our start date. So SARS start date, right? That's going to be the first one. Then this is the date itself. That is the data that is being supplied, this particular date. Then I have to give it a particular format. So the format is going to be this option. So this is the format. So the format is going to be this option. To be capital Y for the year, right? For the year, then it goes on to the next one, which is going to be %M for the month, then %day for the day, right? So that is the simplest stuff, right? Very interesting. It's going to convert it into a datetime format. Then I need to subtract the 100 days for me. So date time dot time delta, right? So I'm adding, not subtracting. So this we are adding to it is going to be 100, so that you'll be able to get the actual date for us. So let's make it like this. So this is the date, right? So this is the actual date. So let's create a simple function to help us with that. So I'll create a function, so we'll get 100 days. And I'm passing the particular start date. So let's go to start date to make it simple. Right, something very simple, like a simple function to make our work easier. Then I'm going to copy the same thing here and then return the result. So let's make it like end date day 100. So I'll pass it as a start date here. Very interesting. Then I'll return day 100. Right, a simple function like that. So let's try it out. So I just go with my get my 100 days to get the 100 day, right? The 100th day. So I'll pass in the same thing I did here. So if I pass in this start dates, hopefully it's going to return the same thing. Perfect, right? So it's able to return it perfectly well. So we have seen how to create a simple function to help us to get our 100 days. So since we have gotten that our 100 days is going to be on seat March, right? On seat, I said 6 March, on seat of the year, which is going to be June of this particular date. We're trying to fetch that particular date and get it for us. So it's going to be our SARS cases. Remember that this is our SARS cases. This is now in datetime format, right? So I can just set it from the first day, which is going to be 2000 which is going to be this option. This month as the beginning till this one, right? Till this particular day that we have. So in that case, it's going to be, so let me copy this one and format it out. Perfect, right? So you have been able to split it like this. You're going to get it in a simple way. So if I run this one here, it's going to only pick from that day to that end, right? So you can actually plot. So this is going to be our 100th day for us. So you can actually plot for 100 days. So let's call this one as our 100 days for SARS. 100 days or 100th day of SARS, right? So let's call it as SARS day 100, right? And then we do the same thing for the Ebola day 100. Then do the same thing for COVID day 100. We're trying to normalize them, right, to see how much or what was the trend for the first 100 days for these particular outbreaks. Very interesting. So that is something very simple. So we're using the same thing that we did above to get these particular values. So I just come back and do for the Ebola and then for the COVID. So it's going to be Ebola. For Ebola. Apologies for how it is, right? So Ebola cases. So this is going to be the start date. So the start date starts from this particular point. So I'll copy this point here. So Ebola start date. So let's call this Ebola start day. Right. This is going to be for the Ebola. Then do the same thing for the other one. which is COVID, right? So COVID cases, COVID started from this particular option, so I'll copy this one here. So this is going to be for my COVID start day. That is the day that they started collecting their data, right? That is what I mean by that. Perfect. So I've gotten it here in a very simple format. Now we can use our function that we did, this particular function, to get our 100 day, to get our 100 day for them. So in that case, it's going to be something like this. So let's go back here, run it again. So this is going to be for Ebola 100, right? Day 100. Then this is going to be COVID 100. So it's going to be this option. So get 100 days. Then I'll pass in the same thing. So this is going to be my COVID start day, right? Very interesting. So this is going to be start day. Okay, so something very simple, right? So this is how it's going to be. So let's make it like this. So I'll copy this, cut this one off. Let's print it out so that we see the days for all of them. So this is going to be for the Ebola, and this is for the for the COVID, right? So you can also do the same thing. So it's going to be my Ebola cases. Not my Ebola, the Ebola cases, right? So the Ebola cases started from this particular option. This was the start date, right? Then we did the same thing. So you can even put the same option here, right? Since this is a string, you can actually put the Ebola start day, right? Then we do the same thing for the other one, which is going to be our daytime option, which is going to be this option, right? So this was going to be, you can actually put that particular variable in case you stored it inside a variable. So that is going to be this variable. Perfect. That is going to be for the Ebola, right? Then let's do the same thing for the COVID. So I'll just go back to this place and go with my COVID cases. Then it's going to be my COVID start day. And I'll do the same thing. If I've stored this one inside a variable, I could have also used it, but let's go with the long format. Okay, so something very simple, right? So you have been able to see how to do that. So if I run this particular stuff, hopefully they're not going to give us any error. So let's take off this. Now we have seen our first 100 days for all of them. Now we can actually plot them, right? Plot them to see what it's doing. So let's do the simple plot. Now let's do some plot for what you have done so far, right? So I just go back to the same thing that we had here, which is going to be for SARS day 100, right? That is the 100th day. So do a simple plot for that. So just group by. If I go back to this and I print it out, you can see it's very well, right? So we have our date column, we have our country, our confirm, right? So I'll just group them, group by, do a simple group by. Group by, I'm grouping by the days, day 100 dot index, right? I'm grouping by the index of it, right? I'm grouping by this particular column, Then I'll just pass in the same thing that we did, which is going to be our confirmed, our dates, and then our recovered cases. Then I'll go with dot max to get the maximum value. So this is going to be perfect, right, for us. Now I can even do a simple plot for this same thing I did. So I'll copy this one here and do another plot. It's going to be a plot to see the distribution. So I can just do a simple plot like plot kind, just go to line, right, and it's going to plot it perfectly for us, right? So you can see from the trend that it went up like this, then it just shoot up, right, for the confirmed date and recovered. So the same thing that we have done, we can also do the same thing for our subplot, for the other plot for the Ebola cases, right? Ebola, and then this Ebola, there was no recovered, as we learned earlier on. If I run it, well, you can see the difference between them. So you can see that from here it just went up like this for the first 100 days, then Ebola just went straight, right? So you can see how the trend was. It rose up went straight, plateaued, went straight up, then it went the other way for the first 100 days. But for Ebola, it was just in a very exponential growth like this, going straight like that, inclined position. I don't know how they call it. Forgotten how they call it. So this is going to be for the COVID. Which is going to be recovered. So this is going to be for the day 100, right? So let's plot it out. I'm going to see the difference between them. So all that we have been doing so far is just to answer one question about the trend, right? And you can see that from the trend here, this is from the first time started to April, right? You can see how it's going, which is totally different from for Ebola, and then this is different from SARS, right? You can see how the SARS trend was. You can also see the same thing for the Ebola, which was more dangerous, and then for the COVID too, right? So we have seen how to answer the first question, or one of the questions for the trend. Now let's move on to do some other stuff, right? So you can just check for the other questions of the top countries affected. So top countries affected. This is going to be like the demographics. So we'll be using the same thing that we did. So we had our Ebola. So let's check for Ebola. So we want to check for the number of countries that have been affected. We can also do the same thing we did. So it's going to be Ebola. So this is checking for top countries affected, right? So we're using a group by. So it's going to be my, let's say, group of countries, right? GPR, or we can just call it any name that you want to be. GRP countries. We're grouping them by countries for Ebola, right? Then it's going to be my Ebola, not my Ebola, but the Ebola cases. Group by, I'm grouping by the country, and then the region. That's the first thing. Then I'll pass in my confirm. So if I go back to this, here we had some confirmed and then dead, right? So that's what you're trying to group by. So let's copy this one. Going to be for confirmed. Confirmed. And then the dead. So this is going to be for the group by. Then I'll just go with max, right? So Ebola had only confirmed and then death. So let's check it out. So if I come back here, I can check it out here in this option. So these are the countries that we have, right? So in case I want to get the country with the highest number of cases, or the number of cases countries that were affected, you can also work on that. So let's try that one out. So you check for countries that were affected. So countries affected. Since we have the group, see me, right? We have it like this. We can actually do a unique to get all the various countries, right, that we have here, right? So these are all the countries that are affected so far. So about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So about 10 countries were affected for the Ebola case, right? That is one way of getting it. You can also use a different format in which instead of using the group by, you can also go with the same thing. So we had Ebola, and I just go with my country / region, right here. Then I'll just go with unique. So this is going to list all the countries here for us, right? So these are all the countries, and I can just do the length of it to get the length of all the countries that were affected, which is about 10, right? So we are confirmed that 10 countries were affected for the Ebola cases. Perfect. So there is the number of countries affected. So number of countries affected. You can also do the same thing for the rest. So this is for number of countries affected. For Ebola, this can be for COVID. Right, which is going to be 183, which is quite a lot. You can also do the same thing for SARS. Right, 36. So from what we have seen, Ebola was the least affected, then followed by COVID, followed by SARS, then by COVID, right? Based on the number of countries that have been affected so far. So just as we did a group by, we can also use the same group by to do some other stuff. So let's try that one to get the top countries that were affected, right? Based on the group by. It would be top countries affected. So we'll be using the same thing, like this is the top 5 countries, the top 10 countries. So we're using the group by that we did. So group. Then I'll just go with n largest. So the n largest takes 2 arguments. So the first argument is going to be the number that you want. So let's say I want 3, right? Then from that I can also specify the particular column I want to use. So I want to get from the column confirmed cases. So based on the confirmed cases, the top 3 countries that were affected based on the confirmed cases is Sierra Leone, Guinea, and then Liberia, right? In case I want to check for the same countries that were affected by death, this is affected by confirmed cases. This is going to be by death, right? So in that case, I'll change this one from here to death. So based on this, you can see which of the countries did well in trying to manage their disease. So here was Sierra Leone was the highest, right? Based on the number of confirmed cases, maybe based on population, but based on the death, Liberia wasn't able to control it very well, right? Liberia had a lot of death cases, more than Sierra Leone. It's almost about 300 difference, or maybe 200 difference. Very interesting. So that is something very interesting for the Ebola. Now let's do the same thing for SARS and then for COVID. So I'll just come back to this place. So I'll copy the same thing here. This was for Ebola. Now let's do the same thing for SARS. It's going to be SARS. I'll just change this one to SARS. Right. Then I can add the recovered to it, because for the SARS we had recovered too. So recovered. Then I will do the same thing for COVID. So I save ourselves time. Perfect. So let's run it out. Perfect. So we have gotten the groups for the countries and then for the based on the disease, right? So for SARS and then for COVID. I can also do the same thing that we did here to check for each and every one of them. So we can do the same thing for the SARS. So this is based on the SARS. So these are the top 3 countries, but I think SARS had a lot of countries. So I can just go with the top 10 countries based on death, which was this option for the SARS, right? So China had the highest, followed by Hong Kong, Taiwan, Canada for the SARS outbreak. And to do the same thing for based on the number of confirmed cases. So in that case, it's going to be confirmed. So it's going to be confirmed. Right, so if I run this one, I'm going to see the top largest country. So still the same thing. We had China being the highest, Hong Kong, Taiwan, Canada, US, Singapore. So these are the top 10 countries that were affected by SARS, right? So we can also do the same thing for the smallest, the countries that were least affected based on what we had, using the same option. In that case, it's not going to be n largest, it's going to be n smallest. I'm going to check for myself. So Belgium was the least affected. Bulgaria, Colombia, Finland, the rest. So Belgium was the least affected for the SARS outbreak. Very interesting. So you can also do the same thing as we have done for the COVID. For now, let's check that one for COVID. So this is going to be a group of countries by COVID. Based on, wow, I'm surprised. Italy has surpassed China. Wow, I'm so surprised of this particular data. Italy has surpassed China based on the deaths, based on the number of confirmed cases. Can also do the same thing for the confirmed cases. So let's go with this option here. See what I did. So this is going to be the number of confirmed cases. Wow, so US had the highest number, followed by Spain, Italy, Germany. But for the deaths, Italy is the highest, right? So that is something very simple. You can also do the same thing for the rest. That is something basic that we can do with all that we have done. Now let's do some simple plots, and then we'll move on to conclude what you have done so far. So this is going to be some simple data viz. So the data viz we'll be doing is going to be on the distribution, right? Geographic. Let's say Geographic. This will be using Geopandas to help us with that. But before then, let's do some simple pie plot for that. So I go with Ebola. I want to group them by countries. Can also do the same thing, country, right? For all the Ebola cases, region. And I can just do a simple value count for the value count. Right, so this option is going to count them perfectly for us. So this is how it is for the country for Ebola. Then I can also do a simple plot for that using the simple pie plot. So let's do a simple pie plot for that. So plot dot pie. Then we do an auto percentage for that. So if I do an auto percentage, hopefully there's no mistake here. So let's check it out. I think there's a mistake. We already got Liberia. I think we made a mistake somewhere. So let's fix that one out. So I corrected it here. So there was a mistake here, right? So this is our plot. I can make it bigger so that it looks nicer by going with plt.figure size. And fig size 2010 is equal to that. At least it looks bigger, right? So based on what you have seen, this is the distribution, right, with the pie plot. Can also do the same thing for Ebola. Done for Ebola. You can also do the same thing for SARS. Then you can also do the same thing for COVID. So this is going to be for SARS. If I run it, this is the distribution for SARS, right? Wow, it's for SARS, and I'm sure for COVID is going to be so much. COVID to be more plenty than for SARS. That is something very simple and something very basic about the distribution. Some simple plots that you have done for analysis so far. Wow, so you can see it very well. Let me change it so that you can see it in a brighter format. Perfect. So you can see it very well, right? So this is something different. So we have been able to do some interesting plots, some interesting analysis. This is just a fun project that we are doing, nothing serious. Now let's do some geographic plots, right? So we're using Geopandas to help us with that. So as we learned earlier on, we're just going with it's going to be using Geopandas, right? So in that case, it's going to be my GDP. Let's call it geodata frame for Ebola. And I'll just go with my GPD dot geo frame, geodata frame, data frame, and I'll pass in my Ebola case. Then not my Ebola geometry. It's going to be what we did previously. So it's going to be GPD dot points from SY. And I'll pass in the various columns, right? So the first column is going to be for our longitude, polar longitude. Then the next one is going to be for the latitude. Right, so something very simple. So this is going to convert it into a Geopanda data frame. Hopefully there's no mistake. Perfect. So if I run it back again, we are going to see that we have gotten our points. Well, right, perfect. So we are using a simple plot to help us to see the distribution of what we have done so far. So let's try that simple plot. So I'll use this word plot. So GDP, right, your data frame. Now read a file. So this is already with the Geopandas already, so we just download it automatically. So gpd.dataset .get path. Then I'll pass in the natural at lowest. low resolution. It's going to give us for the world, right, plot. Then I can just go with a simple ax plot. And then 10. So let's check it out. Hopefully it doesn't give us any errors. Perfect. So these are all plots. So now we'll be mapping them together. We'll be overlapping them. Perfect. So now let's overlap them. So I'll just copy it and paste it to save us time. So we are just doing a simple subplot. Then we are using our Ebola pandas data frame, the one that we converted here, right? This particular data set with our geometry. Then we'll be overlapping it onto our world map here, right? So let's try that one out. So if I run it, we are setting it to map it as purple. So let's run it and see. If I run this simple stuff, it's going to give us a very nice plot, very interesting. So you can see from here that the Ebola was in US, somewhere here, somewhere Chad, Nigeria, Spain. I don't know. Yeah, I think that is Spain. Portugal, Spain, yeah. So it will not found in any part of the Asian countries, right? Very interesting. That is for the Ebola. Now let's try that one for the SARS, right? So the same thing that we did. So I just copy the same thing. So this is going to be for SARS. So I just change this one to SARS. See, I made a mistake here. Same thing that we have done. Then I'll copy exactly the same thing we did and overlap it and try and see. So if I paste it here, let's change this one from, this is for Ebola. Now let's make it for the SARS. Let's see the difference. Perfect. So you can see from here that for the SARS, it was very, very rare in Africa, right? Except South Africa. But it was common in the Asian countries from China, India, Russia, then Europe, then in US and in Canada. But for the Ebola, it was mostly secluded to Africa, US, and then Spain, right? I think this is Spain. I don't know. I think that is Spain. Okay, that is something very simple, right? You have seen. But if you do for the COVID to be worldwide, so from all that you have done so far, I can understand that the COVID is mostly the most extreme based on widespread, right, than the SARS, which is than the Ebola. But the Ebola is the most dangerous, which was secluded in a very limited place. But for the SARS was also in a more broader place. But for the COVID, it was in a very high place. Let's do that one for the COVID. Then we will conclude, because we have taken a lot of time. So this is just a fun project. You can actually sit down and then do more. But this is something very simple to begin with. So COVID. So do the same thing for COVID. So I think I made a mistake again. The same mistake I made the other time is what I'm doing again. So to convert it, then we will do the same plot we did. You can actually overlap the plots and it's still going to work. So if I paste it here, this is for the, we have done for our Ebola, for this was for SARS, right? So let's try for COVID. Let's run it out. So if I run it, it's going to plot it perfectly for us. And it's going to be worldwide because for the COVID it is almost spread worldwide, unlike the rest. So let's check it out, and from here you can see that this is worldwide, right? Almost every place. Even it is so world spread everywhere. That is something very simple that we can do. So of course there are a lot of things you can do. So we have seen how to do some very simple comparative analysis of all of these things. This is just a fun project, right? You can do a lot of things to get a lot of details. So we have seen how to see and answer some of these questions, most of them. So thank you for watching this tutorial. In case you have any question or contribution, you can just put it in the comment section below. And please don't forget to subscribe and check the link below for some interesting materials to help you master machine learning and then Python. Thank you and stay blessed. Bye.